Welcome to the MTD podcast. My name is Rowan East Robinson and I'm a proud member of the MTD team. Today we're going to be talking about hole making, which it might sound like something you want to, is a bit of an afterthought in the machining process, but it is so important. Especially, I know, I'm sorry, Paul. I've started with an insult here,
Wow.
but it's actually so important if you're making engine blocks, you're making pumps, compressors, anything.
There's a hole in anything.
There's a hole in everything, and it's so important how you make that hole, how productive you can be, and how much that cost per hole actually costs you in the machining process. So if you thought hole making was an afterthought, keep listening, because Paul and Amir here are definitely going to be here to convince you otherwise. And without further ado, I'm gonna introduce our guests. I'm here with Paul Crawford and Amir Chvolich. But first of all, Paul, could you please introduce yourself, who you represent, and your background?
I'm Paul Crawford. I'm the Managing Director of Allied Machine Engineering Europe. I'm the third generation of engineer. So my father was an engineer, specifically hole making, and my grandfather was also an engineer, actually in boring tools. So it's pretty much in the blood. We've been doing it for a long time.
You got three generations of hole making expertise.
Three generations, yeah. I don't know whether it was all passed on, but yeah, 3 generations.
I'm sure it passes through the blood, that definitely.
It gets there, yeah. It definitely gets in the blood. And we're based in Kings Swinford, just down the road from here in the West Midlands. Brilliant.
And we're going to be talking about Allied Machine's history in a little bit, which is fascinating. How long Allied Machine, and also, can I say this right, Amir?
Yeah, you can.
Volhaupter,
that is correct.
Volhaupter's history as well, we're going to be discussing, which has been going for a very long time now. Amir, can you introduce yourself, please?
Yeah, sure. My name is Emil Chvolich. I'm head of sales for Volhaupter. I'm still 1 year with the company, so I don't have it in the blood, but actually I worked longer for the company, or half of it. So I pretty much did from applications.
You started
product
off as
management.
apprentice, didn't you?
Yes, apprentice was 15. So yeah, started from the filing of the components to nowadays selling the.
It must be a
products.
fantastic time in the office for you to be there for 31 years.
Yeah, and with all the changes coming along over those decades, it was a interesting road.
There's going to be something to keep it interesting as well over that time.
So we're always going to have that one.
Absolutely. So between Paul's 3 generations and Amir's 30 years, we probably have almost a century of hole-making knowledge. If only your father and grandfather would be here as well, I'm sure it would be a fantastic discussion. But we're going to start with the history of Allied Machine, and it's an American company, isn't it?
It's an American-owned company, yes. It started in a small town, Dover, Ohio. That was way back in 1941. It's a family business. It still is a family business owned by the Stokey family. And they started manufacturing spade drills around about 1942. And we've just progressed through the decades, through hole making and development of the product. So we started in the USA, and now we're really a global company. We have manufacturing in the US, we have manufacturing in Germany, just outside Stuttgart in Frickenhausen. And we have engineers all over Europe, all over the other continents. So
so you have the tech centre in Kings Swinford, near Dudley. But like you say, there's Allied Machine engineers. Are they in every continent?
Yeah, pretty much so. And we generally deal through distribution, so we like to bring the distributors in, get them trained up, same as end users and customers. So we get our distributors trained up, and we make sure they're able to apply the product at end users with the experience that we give them.
And we're going to be talking about kind of the applications and success stories, hopefully. And you brought a couple of bags of chips with you. It's just after lunch. I've just had a sandwich, so unfortunately I can't eat them. I'm not sure I'd want to. There's some stainless steel here. So.
Yeah, different sort of chips. Yeah, our chips.
Absolutely. So coming up, we'll be discussing methods of chip control of stainless steel, specifically in homemaking. So if you're interested in that, then keep listening. But we're going to keep going actually on the history of Allied tooling, and you've like we say, you've got a lot of tech support in the UK and Europe. How important is tech support close to clients?
Yeah, absolutely. Drilling isn't rocket science, but there is a science behind it. Other cycles you have a set surface speed. With drilling, you've got next to no surface speed in the centre of the tool. You're obviously having to get chip formation, chip control out of the hole, especially with deep hole drilling. So every day is a learning curve for us. Every application is different. So having someone there who can apply the product with the customer is really what we're all about. To give the customer a cost per hole advantage. That's what we do on a daily basis.
Absolutely. And it's not just that physical service being there with the customer. You guys actually have a lot of technical knowledge. You have patents on your hole making technology. And I don't know how many people can say, well, no one else can make something exactly like we make it.
Yeah, we came out with the original TA way back in 1985. We've developed it through 30, 40 years. We came out with the Gen 2 in 2004. And last year we come out what we call the TA Pro. So all through the generations, all through the decades, just like some of the cars you see on the road, the development's there. So, that's what we do. That's our bread and butter every day.
So we're going to talk about the TA Pro and the APX, U-drills and spade drills, and how they're best applied and how they can help the listeners here to reduce their cost per hole. But right now, we'll do that a little bit later, but right now we're going to actually move on to Amir now. And onto Volhaupter. Now, Volhaupter, I mean, quite clearly a German brand. It's very well known in Germany, isn't it, Amir?
Oh, yeah. Volhaupter has been in the business since 1929. Not from the early beginning, it was their own product. We started as a job shop, but in 1935, we actually came an application across that Emil Volhaupter needed to design a tool to actually could machine that component to the requirements. So that's how we started to get actually into the tooling business, which called the Volhaupter boring and facing head UPA, which is, I think, worldwide known. I very often hear, hey, I still have a Volhaupter head here in my shop, and it's crazy on where you can find them all around the world. And yeah, over a couple of decades, that was pretty much everything that we sold in various sizes, UPA 1 to UPA 7 S8. And that's how Volhaupter really got into the cutting tool business with his own product.
Absolutely, and I find it amazing. 1929, so that's, if my maths is right, it's 93 years you've been going this year, soon to be 94, I guess, in the new year. So there is a lot of hole making expertise on the Allied machine side, and also on the Volhaupter side. And I think there's a great collaboration there between kind of US and German technology. But you guys have your very own specialism. So Allied machine is all about the really ripping out material for a low cost. And then Volhaupter, this is about really finishing that hole to a fine tolerance. And you were almost the first modular boring system ever out in the market.
Yeah, that is correct. In 1973, we've been the first tool manufacturer that actually offered to the outside world a modular tooling system. And the history behind that was that in around the early 70s, NC machine control came onto the market. So the boring and facing head didn't really match all the time the needs of those machines. So we needed a system that really could build up to machine bores in various sizes, lengths, and so ever. That's where multi-bore started in 1973.
But it's not just the fact that you've got kind of this battle-proven technology. You're still developing almost, I was going to say every day, but the amount of new tech you've got as well, it almost screams a new startup company trying to make waves. So you've got kind of vibration damping, and what you call the third eye, which I absolutely love, the third eye tech, which is kind of a snap-on, a digital adjustable boring bar, which you have a little readout that you can put on your smallest head and your biggest head, which goes up to how big are the biggest heads?
The biggest diameter that we actually can machine and actually can ship right next day is 3,255 millimeter. And
listeners, could you just repeat that for the listeners who didn't quite get that?
3,255 millimeters.
And that can ship next day. So I guess I had noticed, so you guys have got quite a lot of stock as well. Is that in Germany or is that worldwide?
No, we have stock in Germany, but also around the globe. We have sort of facilities that actually have stock available too. And all our products that have the Wallhopter brand name on are also manufactured in Frickenhausen.
Okay, so absolutely fascinating histories, long heritages in making holes. So let's get down to it. First of all, Paul, I think we're going to talk about deep hole drilling, as well as other kinds of hole making, like your standard, like the U drills that you offer. But what makes a deep hole? I mean, are we talking 30 times D, 100 times D? I've seen big deep hole drilling machines. That do
Yeah, anything really over 8 to 10 times D is classed as deep hole drilling for us. We go up to 2.5 metres, 2,500 millimetres with our BTA system. But anything over 8 to 10 times D is classed as deep hole drilling.
And the 2.5 meter BTA system, you've kind of got a head on the table. It's a shame that the listeners can't see this because we've got loads of really cool tech on the table. The BTA system, actually, the chips get sucked through the centre. Is that right?
Yeah, there's two different systems with the BTA. There's a STS, which is a single tube system, where the chips go down the centre of the tube and the coolant on the outside. And then you have a twin tube system where you have the chips caught in between. The standard system is the STS. You generally need for the STS a specialised deep hole drilling machine with a chip box. So it's for specialised deep hole drilling with the geometries that we have. We can get the chips small enough to go down the tube, even in some of the more difficult materials like stainless steels.
So you've covered kind of two significant topics there. One is chip evacuation. So with really deep holes, you need to have you need to think a lot about chip evacuation.
You do.
But you also need to think about the size of the chips, that's kind of the chip control, and that's controlled by, is that the insert geometry?
Yeah, it's not just the geometry, you have to look at the coolant as well. We get, with the TA product, we'll get small 6s and 9s, we call them, and that enables us to evacuate them down the holder. Most applications for deep hole drilling are horizontal, so you've got gravity dropping the chips to the bottom of the hole or to the side of the holder, and then you need the coolant pressure to get the chips out of the hole. So most deep hole drilling, you're looking at 70 bar of coolant pressure, 80, 100 litres per minute. It really depends on the material that you're drilling at the time. But it's important to get the chip control. So you want to drill up to a couple of times D. Just check your chip formation before you go any deeper.
Can the chip formation change throughout the depth of the hole? Or if you do the first 25 mil is okay, then the next 200 mil is going to be fine as well?
Yeah, I mean, there can be differences in the material. The actual grain of the material can be different. We find that with materials that have been heat treated, it may be softer in the centre. So, and when you're standing by the machine, you can see, if it's a short hole, you can see what's happening. If it's a deep hole, it's a lot trickier.
You've got no idea.
You have to look at the telltale signs. So you look at the machine load, if it's starting to spike because it's choking with chips. You can see on the machine load, you can see the coolant flume that's coming out of the hole. If that's starting to be intermittent, you know that the chips are getting stuck in there. If you put your hand on the machine, you feel vibration, that's not constant. It's another thing to look out for. It comes with experience.
Absolutely. We're going to talk about vibration damping as well when we move on to kind of the finishing of the holes with the E-Tech system and the boring systems that Wallhopter offer. But what I find fascinating is, like you say, with a deep hole, unless you've got kind of Superman X-ray vision, there's no way you can even know what's happening down there.
Yeah, it's very difficult. When we first started, we would use high-speed steel. High-speed steel is a lot tougher.
In terms of, we're talking a solid body of high-speed steel?
Sorry, the insert at the front. The insert on the front of the holder, we would use high-speed steel predominantly.
And this is the TA and the TA Pro we're talking about?
This is the TA Pro.
Which are a spade drill.
Yeah, it's a spade drill. I say it started in 1985, and we've developed it now right up to the TA Pro. As a standard, we go up to 32 times diameter deep with a standard holder. So you've got to make sure that you pilot it properly. So you've got to make sure you put an indicator on the tool.
If you've got a 32 times the tool, you can't just start spinning that up, can you?
It turns into a whip. We've seen it happen. It ends up in the ceiling.
I bet it does. I bet it stretches the material at the amount of centrifugal force in there.
It can be scary. So you've got to be careful. You need to make sure you put a pilot hole in, support the tool. And when you're looking at 32 times diameter, maybe one of our specials could be 2 meters deep. Sometimes you have to manually help the tool into the prepared hole.
Oh my God, because it's drooping so much.
Because of the length, so you have to raise the spindle to walk it in.
I guess the game changes a lot when you go from a little kind of stubby carbide drill to a large Is it high-speed steel body, and then
Yeah.
you'll have high-speed steel or carbide
high-strength
inserts?
material. Yeah.
And you've had 40 years of development in the actual insert material, grade, geometry,
Yes.
all of those things. What have you learnt over those 40 years?
Well, as I say, we started with high-speed steel on the longer tools. Now, with the toughness of the carbide, they hold together much better.
Because otherwise they were too brittle and would chip
brittle.
and crack.
Yeah, they were too brittle. We've improved the point geometry, the multifaceted points, so they centre better. So, when you're drilling a deep hole with a TA, the concentricity-wise, because it's not supported like a twist drill or a solid tool, you do get some run out. Okay, so we improved the point so it keeps on its own centre much better. We've improved the coating so they're much more wear resistant.
And these coatings, because you are hole making specialists and you're not cutting tool manufacturers that need to offer a solution for milling, for drilling, for boring, for loads of different applications, you can specify coatings just for drilling. Is that correct?
Yeah, absolutely. Yeah, I mean, we don't do turning, we don't do milling. We're drilling specialists, and we've got new tools like the APX drill, where it's similar to a U drill, but it can go up to 10 times D. So we've got the technology on the point of the TA, and we've got indexable inserts on the diameter. So we've got the best of both worlds.
Absolutely. And I guess there's benefits to a specialist spade drill with your real TA insert, or just going to a normal U drill when you need to kind of those smaller holes.
Yeah. I mean, if you need to get material out of a hole and tolerance is not so good or is open, then a U drill's a good tool. But you need the rigidity. You've got indexable inserts, carbide inserts. They don't like interrupted cuts, for instance. There's some things they don't like. And majority of our holes are deeper holes, larger diameters, but we do right down to 9.5 millimetres. So 9.5 right up to 160 mil with the TA now.
And that is, it's fascinating. You can get a single spade insert that's 160 millimeters wide.
Yeah.
And there is a large difference between the cutting speed on the edge of that and the periphery of
There
that
is.
insert, and also the center of the insert, which you did allude to at the start of the podcast. And does that factor into the choice of high speed steel versus carbide?
Yeah, on the large diameters, then obviously you're looking at the cost. So they're generally high-speed steel.
So this is all. This is again coming back to the point of bringing the cost per hole down.
Yeah. Well, with the APX, we use carbide or high-speed steel in the middle, and then indexable inserts on the diameter. That allows us to lighten the feed rate up, but we've still got the performance because we're running at high speed. But right in the centre of the tool, where you've got very little surface speed, you've got very poor cutting action, then we can use all of the geometries with the TA. So it really is very, very flexible.
So I guess the APX as a U drill is kind of a bit of an all-rounder. You can make the best use of all of that 40 years of development in the center insert,
with the TA.
while also outside of the periphery, it's normal cutting there. So you can just use really good inserts for almost like a standard turning operation.
Yeah, absolutely that. And I mean, a spade drill has its limitations. It's a flat blade. We bought out what we call the Gen 3, the Genesis tool, which is a helical style insert. For outright performance, that's difficult to beat, but that gives you a cone when you're looking at chip control, so it's a bit heavier. So when you're going very deep, when I say very deep, we're talking 32 times D, you've got to look at the lightness of the chips to get that pressure and coolant to get the chips evacuated. So the TA works particularly well in the deeper holes.
And there's also been, with the TA Pro, there's also been a bit of a move towards ISO geometries.
Yes.
And why is that? Why can't you use your own specialized geometries? Why did you move to a standard system?
Well, we have our own geometries, but we find it easier for the customer to designate the insert with an ISO designation. So we've just brought out a new stainless steel geometry for the M-type materials. We've got a P geometry, we've got an N geometry, we've got a K geometry, and it's just easier for the customer. One of the things that we have found, our catalogue, is like a bookend,
Nice.
and we find it easy to understand all the different geometries. Customers, they don't know where to look sometimes. So,
and that's why it's important to help with the people in the local areas, to help customers in their own factories.
Yeah.
And that's exactly what we're going to talk about soon, about case studies, about the bag of chips that you've got in.
Yeah.
So that's coming up, exactly how what success stories you've got for customers, and how listeners at home can also help reduce that cost per part by thinking about their hole making operations. But I'm sorry, Amir, we've been talking about the kind of the roughing, the big high productivity operations. Let's talk about the real fine finishing, the maybe a little bit slower. Some might call it boring, but I definitely don't call it boring. Operations that are so important for loads of different kinds of components. Now, how important is boring as an operation?
Oh, it's always one of the last operations when we talk about finishing on a part. So there's always a lot of pressure on everybody involved to, get a good parts off the machine.
To get it right.
Yeah, and that's the reason nobody really is in favor of it, but it needs to do it.
Yeah,
so that's
no one
the
wants to
reason
do
why
the
you
last operation,
have to have the right tools available with, depending on if we are going deep hole boring. We consider it different to like drilling. Deep hole boring already starts with 5 times D, and limits somewhere about 10 times D.
Is that limit because boring is a single point tool as opposed to drilling, which is kind of supported on all sides?
That is absolutely.
Single point is inherently less rigid and more prone to vibration.
That is absolutely right, because you have a single effective tool, one cutting edge with a radius on, and usually then you have a lot of radial pressure. So that's where the limitations come from, and where you then need specific materials to have vibration damping properties. So we offer there, from the diameter range of 20 millimeter solid carbide, as well as heavy metal that goes up to like around 50 mil. Over 50 mil, we use our Novitec system.
And 50 mil is actually quite a short, system, a short size to then approach to start using the vibration damping. And do you find that it's kind of something people will reach for early on, or is it only if you have a specific problem you'll want to reach for vibration damping?
I would say when you're having problems with, where you actually really cannot get the tool to be silent or not taking any or making any vibrations, you always have the chance to, by reducing speeds and feeds and use up sharp cutting edges, even standard components to get it to run, but it's not really effective or not really, as far as productivity goes, in benefit to the end user.
No, because I guess the speed of the boring operation is nothing to do with trying to up the MRR, the metal removal rate. It's just about trying to achieve that fine surface finish and also the geometrical tolerancing that the part requires. And what kind of tolerances have you seen in the field that you've had to try and hit? What's been a difficult application that you thought, wow, I might struggle here, but actually you've been quite surprised by?
Oh, we getting all kinds of tolerances thrown at us, from IT5 to IT6. Standard-wise is an IT7. There is not a very difficult one to achieve.
So is IT? Sorry, for I guess is IT a German or a European standard? I'm not familiar with IT.
That is a tolerance class. You have an H7, H6, H5 tolerances. That always gives you a tolerance range from your numerical diameter. So yeah. And as smaller the IT number gets, as smaller the tolerance area is.
The scarier it becomes.
Yes, correct.
Okay, that's great. And I guess in Germany you have a lot of automotive manufacturers, and those do they require the tighter tolerance, or do you find it's chemical engineering? What kind of applications require those real tight tolerances, those small IT values?
I think that it's across the board. It's not really specific to one specific industry, depending on more moving components, and components need to fit together, as tighter your tolerances get. And therefore, it's not specific one industry that we are. But like I said, everything on housings, in cast iron, I think there we see a lot of tight tolerances, because moving parts are need later on put together.
And let's talk about materials, actually. Now you mentioned cast iron, and we will cover a bit of stainless steel soon. But cast iron it's got a bit of graphite in. Did someone mention steelite? I think Gareth mentioned there's got a few different materials that affect the abrasion, and how does that affect the finish from a bore you can get from cast iron? Is that not quite as good as maybe a stainless steel or a free cutting steel?
Oh yeah, as cast iron you don't have that nice material that, when you're generating a chip that you actually can cut it off.
It's more of a ripping
It's more of a
operation.
ripping. So therefore, there's other ways on still achieving a good surface finish, even in cast iron, like CBN or with Viper geometry, where you actually can also smooth out the surface finishes in cast irons.
And there's also, we're going to move on to stainless steel in a second,
you're
Paul. But there's also, you've brought in kind of we've not talked about, we've been doing loads of technical corners today, but unfortunately we haven't had time to talk about a burnishing tool, which is actually, it's quite simple. It's kind of like a single static dowel in the middle with like some planetary dowels on the outside. And it's quite fascinating how simple that tool is. And yet, what is it for? What does it achieve? And what can it do? Oh, that's for you, Paul.
Well, it basically takes out the peaks and troughs. Okay, so it's a very simple tool to utilise. We sell reamers, burnishing tools, thread mills. But the burnishing tool is quite an easy tool to use. As I say, you need to get a reasonable hole finish to begin with, and you're just taking those peaks and troughs to flatten out the surface. It's simple to use. It's pretty much off the shelf. It's something we is available under guaranteed application, same as any other of our tools.
And we will talk about guaranteed application, I promise. At the end, I promise, Paul.
I just want to add one to that. And in steel materials, you really can achieve crazy surface finishes. It goes down to like RA 0.2, 0.3, which is like a mirror finish.
That's kind of that's what you can ever hope to achieve as a machinist.
Yeah.
And all you need is to buy a burnishing tool from Allied Machine.
Burnishing tools, I mean, reamers, again, it's one of our excellent products we've got. You can adjust the reamer. With a burnishing tool, you're limited to what the diameter adjustment, but with a reamer, you can adjust the diameter. We have expandable heads, expandable rings.
I've never seen an expandable reamer before.
Yeah, absolutely. So you just recover the lost diameter. And, rather than throw away the reamer or send it straight off for refurbishing, you can adjust the reamer so you can just push out the diameter.
Okay, fascinating. I mean, you'll forgive me, we've not covered in the technical corners, I'm afraid, the thread milling, burnishing, reaming.
Anything about hole making.
Anything to do with hole making. I'm sure you'll be back. We'll be doing some more technical corners in 2023. But let's move on now to the examples you've brought. We all have a good example. You've brought 2 bags of chips, thankfully. One's 316, one's 304. There's no fish to go with them, or some mayonnaise or lemon or pepper, unfortunately, but we'll survive. And also 2 part samples, which are a billet with a few holes in. What are we trying to show here, Paul?
It's really the chip formation. 300 series stainless, austenitic stainless, has always been difficult for Allied. Going back to when we originated the TA in 1985, Wham was on the radio. Yeah. We couldn't get chip control. We'd have to use a PEG cycle. We'd use a PEG cycle to mechanically break the chips, get the chips out of the hole.
You're forcing like an intermittent process.
You're forcing.
Almost.
Then you get more wear on the insert. You're slowing the cycle time down. So it's taken us until 2022 to get a geometry that we're really happy with for drilling the austenitic stainless. So I brought some chips in here. We did an application which was a deeper hole, which was 12.5 millimetre diameter, about half-inch diameter, and this particular hole was 160 millimetres deep. So it's a small diameter. In this material, it's not easy. It's not easy. The customer's using a carbide tool, which is not forgiving at all. It's a single-piece tool.
Is that because not forgiving because it's brittle? It's not quite got the toughness that you need.
Yeah. You always get some vibration, and there's always a little bit of lack of rigidity in any application. When you're using a pure solid tool, you need 100% rigidity as much as you can. Using a 2-piece tool, you get some forgiveness there. So this would have been a very difficult application for us. They were using a solid carbide tool. We went in with the new M Geometry TA Pro, and they were amazed, as we were, with the results.
Amazed by your own product. Hopefully that only ever happens once.
Yeah, I mean, when you've been used to having problems with this material for the last 30 years.
You've been fighting like David and Goliath for 40 years.
What really impressed us was the chip formation and health and safety, because, normally in this material you get very stringy swarf. You're going to have to pull it off the spindle. You know, you go into a lot of companies and they've got a rod there they're having to pull, which is not good for health and safety.
No, and the operator intervention also affects productivity as well as having to deal with sharp chips, which are not good for the operator.
Yeah, I mean, literally there was a swarf bin there with stringy swarf coming out of it, flowing out of it. And at the end of the day, the volume of chips that we got, you know, you could have put in a small bucket. So we're really pleased with it. We're just really getting used to the experience of it, and we're trying to get out as many guaranteed applications as possible to get the experience of it ourselves.
And you just led me into the guaranteed application. It's almost like he knows what he's doing here, Amir. So the guaranteed application is that's kind of I've heard of similar things being done by the companies, but they're nothing as clear and explicit as what Allied Machine offer. What is the guaranteed application?
So we ask for a test objective from the end user, from the customer.
So they can tell you anything. We want to drill this in this material, obviously within reason.
We like the goalpost to remain in one place, you know.
So they'll send you a sheet saying we need to achieve this.
Yeah, and so it may be cost per hole, maybe performance, maybe tool life, maybe just a consistent, reliable operation. So we look at it. We'll look at what inserts we can offer. We'll basically send a holder and the appropriate inserts with our recommendations, which we guarantee. So we expect it to work, and generally it does. If the customer has any issues, we just speak to one of our application engineers. We may need to change things slightly because the coolant pressure may not be high enough or whatever. And then if that doesn't work, then basically we'll have the tools back and we credit for the tools. So, it's what we do.
So you take the tools back, you credit for them. It's almost like they didn't have to try it all. There's no risk in taking on an Allied guaranteed application.
There's no risk, but obviously the customer's time is just as important.
Yeah.
So, we appreciate them putting our tools on their machine and testing the tools.
But if you imagine the time taken to do a demo could be half a day to test everything out, get it up and running, but the time taken in lost productivity could be 10 times, 100 times that.
Yeah, absolutely. And that's what we're all about is proving the cost per hole to the customer. That's what basically our meaning is, to get the cost per hole down.
We get it. So specialists in hole making for both roughing, finishing applications, but making sure it's a cost-effective operation. That's been Allied Machine and Wohlhaupter, if I can still try and say that right. Thank you very much, Paul, and danke schön, Amir. Any final comments? Anything you want to say?
No, just thank you for welcoming us in, and look forward to doing it again sometime, and maybe show you a bit more of our tooling online.
Brilliant. So if you've got any questions for either Amir or Paul, get in touch on all the social media channels. That's at MTDCNC. Allied Machines, alliedmachine.com if you're interested and you want to get a guaranteed application. That is a no risk for yourself except the time you've taken to try the demo. I don't think you can say fairer than that. Thank you very much for listening to the MTD podcast, and we'll hope to see you again soon.
Thanks for listening to the MTD podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on mtdcnc.com.